Every time you look up at the night sky, you are in truth looking backward in time. The sky above you carries an unusual stillness. Amid the rush of daily life, the stars appear steady and reliable, as if they have remained unchanged for thousands of years. Yet there is a quiet, distant truth within that calm. What reaches your eyes is never the present moment. Tonight is not a dry astronomy lesson. It is an invitation to pause, to notice that we have never truly been separate from the universe. Light does not arrive instantly. It travels patiently across billions of kilometers, carrying the record of journeys already completed. By the time that light reaches your eyes, it has already become part of the past. Some rays of light began their journey when our grandparents were still young. Others set out long before humanity learned how to name the stars. We are not simply seeing light. We are witnessing the memories of the universe. Standing before such vastness, it is natural to feel small. Yet, telescopes allow us to draw that distance closer. They are not only physical instruments, they are time machines, enabling us to touch history written in light. Tonight, let curiosity guide you as we explore how humanity uses telescopes to read the old luminous journals of space. And from here, without effort, we begin. When you look through a telescope, it may feel as though you are simply bringing distant objects closer. The moon appears sharper, Jupiter grows larger. A faint point of light becomes a star with character and presence. But what the telescope truly offers is not magnification alone. It offers time. Distance in the universe is never just distance, it is duration. Light must move, and movement requires patience. Nothing you see arrives instantly, no matter how clear or powerful the instrument in your hands may be. This is why looking farther into space is inseparable from looking deeper into the past. The moon is the closest companion in this quiet arrangement. Its light takes just over a second to reach Earth. When you look at the moon through a telescope, you are not seeing it as it is in this precise moment. You are seeing it as it was a moment ago. The difference is small enough to feel insignificant, yet the principle is already complete. Even here, time has entered the picture. Your eyes receive an image that has already finished its journey. The moon you observe is always slightly behind itself. Reality, even at its nearest, never fully arrives on time. This delay grows as you turn your attention outward. Jupiter, massive and calm, reflects sunlight that has crossed the inner solar system before reaching you. When you observe its cloud bands, its slow rotation, its quiet storms, you are seeing Jupiter as it existed tens of minutes ago. During that interval, Earth has continued to turn. Jupiter has continued to move. Space itself has shifted, gently, without pause, and yet the image remains stable, as though frozen. This stability is comforting. It gives the impression that the universe is fixed, orderly, dependable. But the calm you perceive is made possible only by delay. What you see has already happened. The telescope does not break this rule. It honors it. As you extend your gaze beyond the planets, the distances lengthen and time stretches with them. Stars appear, no longer as wandering lights, but as distant suns, each carrying its own history. Sirius, the brightest star in the night sky, feels immediate and close. Its light is strong enough to cut through the darkness with ease. Yet even Sirius is not present. The light reaching you tonight left that star more than 8 years ago. When you look at Sirius, you are not seeing it as it is now. You are seeing it as it was when the world was quietly different. 8 years is not a long time by cosmic standards, but it is enough for lives to change, for seasons to pass, for stories to unfold. The star does not know who is watching. It simply sends its light outward, indifferent and steady. You receive what survives the journey. This is not a flaw in observation, it is the structure of reality. Telescopes do not correct for time, they reveal it. With each increase in distance, the universe begins to arrange itself like a layered archive. Nearby objects exist in a relatively recent past. Distant objects belong to older chapters. You are not surrounded by a single moment in time. You are immersed in many moments at once. Space rarely gives us simple answers. When your gaze reaches beyond individual stars and begins to settle on entire galaxies, the sense of time becomes more pronounced. The Andromeda Galaxy, a faint smear of light to the naked eye, is revealed through telescopes as a vast system of stars, dust, and motion. Its light has been traveling for more than 2 million years. 2 million years ago, there were no cities, no written languages, no shared memory of history. The light now entering your eyes began its journey long before humanity learned how to wonder about its origins. And yet it arrives calmly, without urgency, without announcement. The telescope allows you to receive it. This is where the idea of telescopes as time machines quietly becomes unavoidable. Not in the sense of movement or control, but in the sense of access. You are granted a view into moments that no longer exist anywhere else. The past does not linger in space, waiting to be discovered. It travels forward as light, thinning and fading, until it either reaches something capable of receiving it or disappears into silence. Silence is also a kind of data. Every point of light you observe has survived distance, interference, and time. What you see is not a complete record, but a filtered one. Only what endures arrives. In this way, the universe creates its own natural map of time. Nearby objects occupy the most recent layers. Farther ones belong to older eras. The most distant light comes from periods so early that the universe itself was still learning its shape. You do not need charts or calculations to sense this. You feel it intuitively when the sky deepens and the familiar constellations dissolve into unfamiliar structures. The telescope does not flatten this experience, it deepens it. Each adjustment of focus becomes an adjustment of error. Each increase in distance becomes an expansion of memory. What feels like exploration is also reading. Numbers whisper more than they speak. This way of seeing changes how you relate to the night sky. The stars are no longer decorations or symbols. They are records. They carry information about conditions that no longer exist, environments that have already evolved, processes that may have ended long ago. When you observe them, you are not intruding. You are listening. There is something humbling in realizing that the universe offers no synchronized present. There is no shared moment that all things occupy together. Everything you see belongs to a different time, arranged by distance, arriving in quiet order. The telescope simply reveals what was already true. It does not bring the past closer. It allows you to notice that you have always been surrounded by it. This realization does not demand urgency or action. It invites stillness. You begin to understand that observation itself is a gentle act. You wait. The light arrives, you receive it. And in that exchange, without effort, you begin to sense the universe not as a place you stand within, but as a continuum you are already part of. From here, the view only grows deeper. Light feels immediate in everyday life. You turn on a lamp, and the room responds at once. You look at a familiar face, and it seems present without delay. For most human experience, light behaves as if it has no travel time at all. This impression is understandable. Light moves fast enough that across ordinary distances, its journey is effectively invisible. The gap between cause and arrival is too small to notice. And so, for centuries, it was natural to assume that light simply appeared where it was needed. But the universe does not share our sense of immediacy. Beyond the scale of daily life, light reveals a different character. It moves at a fixed speed, steady and unhurried, never faster, never slower. This speed is immense by human standards, yet it is not infinite. And that single fact quietly reshapes everything you see. The realization did not arrive through abstract theory or advanced instruments. It emerged from careful attention and patience. In the late 17th century, a Danish astronomer named Ole Rømer was studying the motion of Jupiter's moons. His work was not dramatic. It involved repeated observation, note-taking, and the quiet discipline of comparison. Night after night, he watched the predictable dance of these distant bodies, expecting their movements to follow a regular schedule. At first they did, but over time, something subtle appeared. The eclipses of Jupiter's moons did not occur exactly when expected. Sometimes they arrived a little early. Sometimes they arrived a little late. The difference was small but consistent enough to demand attention. Rømer noticed that these delays followed a pattern. When Earth was moving closer to Jupiter, the eclipses seemed to happen sooner. When Earth was moving farther away, they appeared later. The moons themselves had not changed their rhythm. The distance had. This was not an error in observation. It was a message carried quietly by light. Rømer understood that the delay was not caused by Jupiter or its moons, but by the time it took light to travel across the changing distance between planets. When Earth was farther away, light needed more time to reach the observer. When Earth was closer, the journey was shorter. For the first time, light was revealed not as an instant messenger, but as a traveler. Space rarely gives us simple answers. This insight did not rely on knowing the exact speed of light. It relied on recognizing that light had a speed at all. The universe had introduced a limit, one that could be measured not by force, but by patience. From that moment onward, distance and time could no longer be treated as separate ideas. Every observation carried a delay. Every image arrived with a history. What Rømer uncovered was not just a scientific fact, it was a shift in perspective. The universe was no longer something you observed in real time. It was something you received. This realization carries a quiet human weight. It reminds you that perception is never immediate, even when it feels that way. What you see has already happened. What you hear has already passed. The present moment is always slightly out of reach. And yet, this delay does not diminish meaning. It creates it. The finite speed of light turns the universe into a layered experience. Near events feel recent. Far events feel ancient. But all of them arrive in the same gentle way, as light completing a journey. Silence is also a kind of data. Between the moments that arrive and those that never do, the universe quietly selects what can be known. Only light that survives distance, obstruction, and time becomes part of observation. Everything else fades without record. This is not loss, it is structure. Once light was understood to have a speed, telescopes became more than tools of enlargement. They became instruments of timing. Each improvement in observation did not remove delay. It revealed it more clearly. The farther you look, the longer the light has traveled. The clearer the image, the more carefully you are reading a message written long ago. This understanding does not demand urgency or control. You cannot speed light up. You cannot force it to arrive sooner. You can only wait and receive what reaches you. There is something deeply human in this arrangement. Knowledge does not rush toward you. It arrives when it arrives, shaped by distance and circumstance. Numbers whisper more than they speak. The speed of light, though measurable, is not meant to impress. Its significance lies not in how fast it is, but in the fact that it is limited. That limit gives the universe depth. It gives observation meaning. It gives history a place in every image. As you settle into this idea, the night sky begins to feel different. Not closer, not farther, but layered. Each point of light occupies its own moment, its own position in time. Nothing you see is late, nothing is early. Everything arrives exactly as it must. And in that quiet certainty, you begin to sense that waiting is not an obstacle to understanding, but part of its design. As you continue to look outward, distance no longer behaves as a simple measure of space. It becomes something quieter and more complex, shaped by the way the universe itself changes over time. Light still travels, patiently and steadily, but the space it crosses is not fixed. It stretches, it expands, and in that slow expansion, light is altered in subtle but meaningful ways. This idea is not immediately intuitive. In daily life, space feels stable. A room does not grow while you cross it. The ground beneath your feet does not quietly widen as you stand still. Yet on cosmic scales, space is not a rigid stage. It is active, dynamic, and continuously unfolding. As galaxies move away from one another, they are not simply traveling through space. They are being carried by space as it expands between them. When light moves across this expanding fabric, it is gently stretched along the way. Its wavelength grows longer, shifting toward the red end of the spectrum. This is known as redshift, not as a dramatic effect, but as a quiet consequence of cosmic motion. The farther light has traveled, the more space has expanded beneath it, and the more it has been stretched. What arrives at your eyes is still light, still information, but it carries the imprint of the universe's growth. This stretching does not damage the message, it transforms it. By measuring how much the light has been shifted, astronomers gain a sense of how far it has traveled and how much the universe has changed during its journey. Distance and time remain inseparable, woven together by expansion. Space rarely gives us simple answers. There is something deeply human in the way this information is gathered. No one watches space expand in real time. No one feels it happening. Instead, understanding comes from careful comparison, from noticing tiny differences in light that reveal vast truths. Numbers whisper more than they speak. As you look deeper into the universe, redshift becomes a kind of clock. Nearby galaxies show little change. Their light has crossed space that has not had much time to stretch. Distant galaxies tell a different story. Their light has been traveling for billions of years, carried across an expanding universe that has grown larger and cooler over time. Each photon arrives with a record of that expansion written into its color. Yet, the journey of light is shaped by more than expansion alone. Between galaxies and within them lie vast regions filled with dust. These particles are small, often no larger than grains of smoke, but their influence is persistent. Dust does not announce itself. It absorbs and scatters light quietly, altering what reaches you in ways that are easy to overlook. As light passes through dusty regions, some wavelengths are absorbed more than others. Blue light is scattered more easily, while red light passes through with less resistance. The result is a subtle dimming and reddening of distant objects. What you see is not false, but it is incomplete. The universe does not hide information intentionally. It simply filters it through its structure. Silence is also a kind of data. Dust reminds you that observation is never direct. Every signal is shaped by what it encounters along the way. The image you receive has already been edited by distance, expansion, and matter. Understanding requires patience, correction, and humility. Astronomers learn to read these changes carefully. They compare the light from known sources with what arrives after crossing space. They account for dust, for redshift, for the long path traveled. In doing so, they reconstruct not just where an object is, but how the universe has behaved while the light was in transit. This process is slow by design. There are no shortcuts through expanding space. Light cannot choose a clearer path. It moves forward indifferent to obstacles, carrying whatever remains when it arrives. For those who observe, there is a quiet acceptance in this. You are not witnessing the universe as it is now, nor as it once was in isolation, but as it has been shaped by everything in between. Each image becomes a collaboration between source, space, and time. The farther you look, the more this collaboration deepens. Light from the early universe arrives, stretched almost beyond recognition. Its wavelengths are so long that they slip from visible light into forms your eyes cannot see without assistance. What was once bright and energetic becomes faint and gentle, detectable only through careful listening. Numbers whisper more than they speak. In this way, the universe offers depth without urgency. It does not rush its story forward. It allows time to unfold naturally, leaving traces that can be read by those willing to wait. Expansion does not erase the past. It preserves it in altered form. Dust does not block understanding. It teaches caution. It reminds you that clarity is earned, not given. As these ideas settle, the night sky begins to feel less like a window and more like a passage. Light arrives carrying more than images. It carries the memory of space itself, stretched, filtered, and transformed by the universe's slow evolution. Nothing you see has traveled untouched. Nothing arrives unchanged. And yet, what remains is enough. And as you rest within that thought, you sense that distance is not something to overcome, but something to listen to patiently and without demand. As the gaze continues to move outward, there comes a point where familiar structures begin to fade. Galaxies thin out. Stars no longer appear as individual sources. The universe grows quieter, not because there is nothing left, but because the remaining signals are older, softer, and harder to recognize. This is where observation reaches a natural boundary, not imposed by technology, but by the history of the universe itself. Long before stars formed, before galaxies gathered into recognizable shapes, the universe existed in a very different state. It was hot, dense, and filled with light that could not yet travel freely. Space was crowded with charged particles, constantly scattering photons, preventing light from moving in straight lines. In that early era, the universe was bright but opaque. Light existed everywhere, yet it could not go anywhere. As the universe expanded and cooled, a quiet transition took place. Particles combined into neutral atoms, and space became transparent for the first time. Light was finally released to travel uninterrupted across the cosmos. That moment did not announce itself. It simply happened, and the light began its long journey outward in all directions. What remains from that release is known as the cosmic microwave background, often shortened to CMB. It is not a picture of stars or galaxies. It is a faint afterglow, filling all of space, arriving evenly from every direction. It does not belong to a place. It belongs to a time. The light you receive from the CMB has been traveling for nearly the entire history of the universe. It began its journey more than 13 billion years ago, long before any structure existed that could resemble a night sky. Over time, the expansion of space stretched this light dramatically, shifting it far beyond visible wavelengths. What was once intense and energetic has become gentle and cool, detectable only with sensitive instruments designed to listen rather than look. This light marks the farthest boundary of what can be observed directly. It is not the edge of the universe, but it is the edge of visibility. Beyond it, Light has not yet had time to reach you, or never could. The universe continues beyond this boundary, but its earlier moments are hidden, not by distance alone, but by the physics of its own beginnings. Space rarely gives us simple answers. There is something deeply human about recognizing a limit. Telescopes grow more powerful, detectors become more precise. Yet even the most advanced instruments eventually meet a horizon that cannot be crossed by observation. The CMB is that horizon, a quiet reminder that knowledge unfolds within constraints. What makes this boundary remarkable is not only its distance, but its uniformity. Wherever you look, the background appears nearly the same, with only the slightest variations in temperature. These tiny differences, measured in fractions of a degree, carry enormous meaning. They represent the earliest imprints of structure, small irregularities that would, over billions of years, grow into galaxies, clusters, and vast cosmic webs. To read this information requires patience and restraint. There is no dramatic image to admire. The signal is subtle, almost featureless at first glance. Yet within that quiet pattern lies a record of the universe at an age when it was still learning how to take shape. Numbers whisper more than they speak. The CMB does not tell its story through brightness or color. It speaks through precision, through tiny shifts, through patterns that emerge only when noise is carefully removed and distractions are set aside. It rewards attention, not urgency. In this way, the CMB invites a different relationship with knowledge. You are not observing an event. You are receiving a remnant, a message that has survived expansion, cooling, and time itself. It arrives without urgency, filling the space around you evenly, indifferent to whether anyone is listening. Silence is also a kind of data. The smoothness of the CMB tells you something just as important as its variations. It reveals that the early universe was remarkably uniform. That uniformity allowed structure to emerge gradually, without chaos or collapse. It suggests a beginning that was balanced, not violent in the way human imagination often expects. Standing before this realization, it becomes clear that the universe does not reveal its deepest truths through spectacle. It offers them quietly, through signals that require patience to interpret. The boundary marked by the CMB is not a wall, but a surface, one that reflects the limits of what light can show. Beyond this surface lies an era inaccessible to direct observation. Not because it is forbidden, but because it left no light that could travel freely. What happened before that moment can be inferred, modeled, and reasoned about, but not seen in the same way. The universe allows understanding, but not complete access. This boundary reshapes the meaning of looking far away. You are not just reaching across space. You are reaching backward toward a time when the universe itself was young. Each observation carries you closer to that origin, until you reach the earliest light that could ever arrive. There is humility in stopping there. The CMB does not close the story. It frames it. It defines the deepest layer of the cosmic archive that light can provide. Everything closer than this boundary belongs to a later chapter. Everything beyond it exists outside direct view. As you rest with this idea, the universe begins to feel less like an endless expanse and more like a narrative with a beginning that can be sensed but not fully revisited. The light that reaches you tonight has traveled as far as light can travel from the past. And in that gentle limit, you are reminded that understanding does not require total access, only attentive listening, and the patience to accept where vision must finally give way to quiet knowing. After reaching the natural boundary set by the earliest light, it may seem as though there is nowhere left to look. And yet, modern telescopes continue to deepen the view, not by crossing that boundary, but by approaching it with greater clarity and patience. They do not push past the limits of time. They refine how carefully the remaining light is received. For much of human history, the night sky appeared largely unchanged. Even the earliest telescopes revealed only modest improvements: sharper stars, clearer planets, faint smudges where nothing had been seen before. Progress came slowly, shaped by glass, mirrors, and steady refinement rather than sudden leaps. Then instruments left Earth. The Hubble Space Telescope marked a quiet turning point. Freed from atmospheric distortion, it offered a steadier gaze, one that did not flicker or blur with the movement of air. What Hubble provided was not only sharper images, but consistency. The universe appeared calmer when seen without the interference of Earth's atmosphere, as though the sky itself had settled. With this stability came the ability to look longer. Exposure times grew. Faint light was allowed to accumulate patiently, photon by photon. Objects once invisible began to emerge, not suddenly, but gradually, as persistence replaced haste. This approach reached a profound expression in what became known as deep field observations. Rather than scanning across the sky, Hubble was pointed at a region that appeared nearly empty. No bright stars, no obvious galaxies, just darkness. And then it waited. Over days and weeks, light collected. The darkness softened. Points appeared. Shapes emerged. The empty patch of sky filled with thousands of distant galaxies, each one carrying light that had traveled for billions of years. The result was not dramatic in tone, but overwhelming in meaning. What seemed like nothing was revealed to be rich with history. Numbers whisper more than they speak. The deep field images did not show the farthest objects possible. They showed what becomes visible when patience is allowed to replace motion. The telescope did not move farther. It listened longer. This principle carries forward into modern astronomy. Seeing farther is not always about building larger instruments. It is about learning how to receive weaker signals with greater care. James Webb continues this approach, but in a different register. Where Hubble primarily observed visible and ultraviolet light, Webb listens to longer wavelengths. It is tuned to infrared, the stretched and softened light that arrives from the most distant and ancient sources. This choice is not arbitrary. As space expands, light from the early universe is shifted beyond visibility. What once glowed brightly becomes quiet and cool by the time it arrives. Webb does not attempt to recover lost brightness. It meets the light where it is. There is a subtle humility in this design. Instead of forcing the universe to appear as it once did, the telescope adapts itself to what remains. James Webb looks outward and backward by listening to warmth rather than brightness. The faint heat of distant galaxies becomes a signal. Structures hidden behind dust become visible. Star formation that was once obscured emerges softly. Silence is also a kind of data. This sensitivity allows Webb to observe galaxies forming closer to the beginning of cosmic time than ever before. These are not fully formed systems. They are uneven, evolving, sometimes irregular. Their light arrives stretched, incomplete, shaped by the long path it has traveled. What Webb reveals is not a finished universe, but one in progress. In this way, modern telescopes do not simply extend vision. They deepen understanding of time itself. Each improvement allows light that once faded into noise to become part of the record. Deep field observations continue with Webb, now reaching even farther. The same method is used. A small, unremarkable region of sky is chosen. The telescope remains fixed. Light accumulates. What emerges is a layered image of cosmic history. Nearby galaxies appear brighter and more defined. Farther ones are smaller, fainter, more numerous. The most distant appear as subtle distortions, barely distinct from background glow. Space rarely gives us simple answers. The farther the view extends, the less familiar the universe becomes. Shapes grow less orderly. Structures appear incomplete. This is not a failure of observation. It is an accurate reflection of a younger cosmos, one still organizing itself. For those who look, there is a quiet adjustment required. Expectations shaped by the nearby universe must be released. The early universe does not resemble the present. It offers fewer patterns, fewer stable forms. Modern telescopes allow this difference to be seen without judgment. They do not correct the past. They reveal it. There is also a human dimension to this work that is easy to overlook. These observations are not made in isolation. Teams decide where to look. They choose how long to wait. They interpret signals that sit at the edge of detection. Each image represents collective patience, shared restraint, and a willingness to accept uncertainty. Knowledge arrives slowly. It does not reward urgency. Even with these instruments, there is no single farthest object that can be named definitively. Visibility depends on wavelength, exposure time, and the quiet presence of noise. The question is not how far a telescope can see in absolute terms, but how gently it can listen. Numbers whisper more than they speak. What modern telescopes truly offer is not conquest of distance, but refinement of attention. They allow the faintest messages to be heard without distortion, without haste. They approach the edge of visibility not by force, but by care. As you consider this, the idea of looking far away becomes less about reaching outward and more about receiving inward. The universe does not rush to meet the observer. It reveals itself when given time. Each deep-field image is not a snapshot, but a conversation across billions of years. Light arrives carrying memory, shaped by expansion, dust, and time. The telescope becomes a place of reception, not control. And as the view extends, you are reminded that seeing farther does not mean seeing everything. It means seeing what remains, and accepting that what remains is enough to continue understanding. From here, the universe does not grow louder. It grows quieter, more delicate, inviting a different kind of attention, one that listens rather than seeks, and waits without expectation. When modern telescopes look far enough, they begin to reveal a universe that feels unfamiliar, not because it is chaotic, but because it is young. The light arriving from these great distances carries you back to a time shortly after the universe first became transparent, when structure had not yet settled into the forms you recognize tonight. This is the era of the earliest galaxies, emerging quietly from a cosmos that was still cooling, still expanding, still learning how to organize itself. After the Big Bang, the universe did not immediately fill with stars and galaxies. For a long time, it remained dark. Matter existed, spread thinly through space, but it had not yet gathered. Gravity worked patiently, drawing small irregularities together, slowly amplifying differences that were once barely noticeable. Over millions of years, these faint imbalances grew stronger, allowing the first dense regions to form. Where matter gathered, gravity deepened its pull, and the long process of structure began. The first galaxies did not resemble the graceful spirals or smooth ellipses seen nearby today. They were smaller, less orderly, often irregular in shape. They formed quickly, using the simplest materials available, mostly hydrogen and helium. Heavier elements had not yet been created in abundance. There had been few generations of stars to enrich space with complexity. The universe was chemically young. When stars first ignited within these early galaxies, they did so intensely. With abundant fuel and little competition, star formation proceeded rapidly. Many of these first stars were massive and short-lived, burning bright and ending their lives quickly. Their deaths seeded space with heavier elements, quietly preparing the conditions for future generations of stars and planets. This process unfolded without intention or urgency. No moment marked the arrival of the first galaxy. No boundary separated darkness from light. Instead, the universe transitioned gradually, almost imperceptibly, from simplicity to structure. Space rarely gives us simple answers. Observing this era requires accepting uncertainty. Light from these early galaxies arrives stretched and faint, shaped by the long journey it has taken. Their images are incomplete, sometimes blurred, sometimes fragmented. What you see is not a finished picture, but a glimpse through layers of time, expansion, and dust. Understanding comes not from clarity alone, but from careful interpretation. There is something deeply human in this kind of observation. You are not witnessing a dramatic beginning. You are witnessing emergence, small structures growing into larger ones, order appearing slowly without guidance, driven only by gravity and time. These early galaxies existed in an environment very different from the one that surrounds the Milky Way today. Space was warmer. Radiation was more intense. Interactions between young galaxies were common, as distances between them were smaller. Mergers occurred frequently, reshaping structures before they had time to settle. Growth was uneven, shaped by encounters as much as by internal processes. Yet even in this restless environment, patterns began to form. Regions of higher density attracted more matter. Filaments emerged, connecting growing systems across vast distances. The large-scale structure of the universe, still visible today, was already taking shape, faintly outlined in the early distribution of galaxies. Numbers whisper more than they speak. From these early observations, astronomers do not seek dramatic confirmation, but consistency. They compare light from many distant sources, looking for shared characteristics, repeated behaviors, subtle trends. Each small agreement strengthens the picture. Each discrepancy invites patience rather than urgency. There is also humility in recognizing how much remains unseen. The earliest galaxies are not fully accessible. Some lie beyond detection. Others are hidden behind dust or overwhelmed by foreground light. What reaches us is only a portion of what once existed. Yet this partial view is enough to trace a story. Silence is also a kind of data. The gaps in observation matter. Regions where no galaxies appear help define the limits of structure. Absences shape understanding as much as presences. The early universe was not evenly populated. It was textured, uneven, gradually organizing itself into the patterns that would persist for billions of years. As you reflect on this era, it becomes clear that the universe did not rush toward complexity. It allowed time to do its work. Stars formed, lived, and ended their lives, contributing quietly to the environment around them. Galaxies grew not through design, but through accumulation and interaction. Nothing was wasted, nothing was hurried. This slow unfolding invites a shift in perspective. Progress, in the cosmic sense, is not measured by speed or efficiency. It is measured by endurance. Structures that lasted were those that could persist, adapt, and grow within changing conditions. When you look at the faint light from the earliest galaxies, you are not seeing a beginning in the way stories often describe beginnings. You are seeing continuity. The same physical laws that govern the universe today were already at work then, shaping matter with the same patience, the same restraint. The universe does not reset itself. It builds upon what came before. As modern telescopes refine this view, the early universe feels less distant and less abstract. It becomes a chapter rather than a mystery. A chapter written in light that has traveled long enough to arrive quietly, without announcement. And as you rest with this image of a young cosmos, filled with forming galaxies and newly ignited stars, you may sense that the universe has always favored gradual emergence over sudden change, allowing time itself to serve as the primary architect. From here, the story continues forward, shaped by stars that are born, live, and fade, leaving behind traces that guide what comes next, always moving, always unfolding, and never needing to hurry. As the universe continues to mature, stars become its most patient storytellers. They do not appear suddenly, nor do they vanish without leaving traces behind. Each star follows a quiet arc shaped by gravity, fuel, and time, an arc that unfolds over millions or billions of years. When you observe a star, you are not witnessing a single moment, but a chapter within a much longer process, one that began long before the light reached you, and will continue long after it fades from view. Stars are born in regions that appear calm from a distance. Vast clouds of gas and dust drift through space, cold and dark, offering little hint of what they contain. These clouds are not uniform. Small differences in density allow gravity to begin its work. Slowly, almost imperceptibly, matter gathers. As it does, pressure and temperature rise. What was once diffuse becomes concentrated. What was once silent begins to warm. There is no clear line where a cloud becomes a star. Formation is gradual. As the center grows denser and hotter, nuclear reactions begin. Hydrogen atoms fuse into helium, releasing energy. Light emerges, not as an announcement, but as a natural consequence. A star has begun its life. From this moment, the balance between gravity and energy defines everything that follows. Gravity pulls inward, energy pushes outward. For long periods, these forces remain in quiet equilibrium. The star shines steadily, converting mass into light, sending energy into surrounding space. This phase can last for most of a star's existence, a long middle age marked by stability rather than change. The duration of this phase depends on mass. Smaller stars burn their fuel slowly, conserving energy, enduring for billions of years. Larger stars consume fuel quickly, shining brightly but briefly. Mass determines tempo. Time responds accordingly. Numbers whisper more than they speak. When you look at the night sky, you see stars at different points in this cycle. Some are young and newly formed. Others have been shining longer than life has existed on Earth. Still others are approaching the end of their fuel supply, preparing for transitions that will reshape them completely. The sky is not a snapshot. It is a composite of many lifetimes, layered by distance and time. Eventually, change becomes unavoidable. As a star exhausts the hydrogen in its core, balance shifts, gravity gains the upper hand. The core contracts, surrounding layers respond. New reactions begin, fusing heavier elements. The star enters a new phase, expanding or brightening, depending on its mass. What appears calm from afar is, in truth, a complex rearrangement driven by physics rather than intention. For smaller stars, this transition is gentle. They shed outer layers slowly, creating expanding shells of gas that drift outward into space. What remains is a dense core, a white dwarf no longer generating energy through fusion, but still glowing faintly with stored heat. Over immense spans of time, it cools, fading quietly into darkness. For more massive stars, the process is shorter and more complex. Heavier elements form in layers, each reaction producing less energy than the last. When fusion can no longer support the core, gravity overwhelms the structure. The star collapses inward, and outer layers are expelled into space. The result is a supernova, not as an act of violence, but as a redistribution of matter. Space rarely gives us simple answers. What remains after such a collapse depends on mass. In some cases, the core becomes a neutron star, incredibly dense, spinning quietly, emitting signals that can be detected across great distances. In others, collapse continues beyond visibility, forming a black hole defined not by what it emits, but by what it prevents from escaping. These remnants are not endings in the human sense, they are transitions. The material expelled during a star's final stages enriches the surrounding environment. Elements forged in stellar interiors become part of new clouds, new systems, new possibilities. Carbon, oxygen, iron, and countless others disperse, contributing to future generations of stars and planets. Silence is also a kind of data. Much of this process unfolds unseen. Stellar interiors remain inaccessible. Remnants can be faint, distant, or hidden behind dust. Yet absence itself carries information. Gaps in observation hint at processes beyond direct view. Patterns in motion and radiation reveal what cannot be imaged directly. There is something quietly humbling in this cycle. Stars do not persist indefinitely. Even the longest-lived will eventually exhaust their fuel. Yet nothing is wasted. Matter is reused, structure evolves. The universe does not favor permanence. It favors continuity. For observers, this understanding reshapes the meaning of starlight. Light is not just illumination, it is evidence of ongoing transformation. When you see a star, you are witnessing energy released long ago, sustained by processes that may already have changed or ended. The star you observe may no longer exist in the same form. Its light continues forward, carrying the memory of its state at the time of emission. This realization brings a gentle shift in perspective. Life cycles are not unique to living things. They are woven into the fabric of the universe. Growth, stability, change, and transition occur on scales far beyond human experience. Yet they follow principles that feel quietly familiar. Stars are born without intention. They live without awareness. They change without regret. And yet their existence shapes everything that follows. Planets form from their remnants. Chemistry evolves. Complexity becomes possible. Numbers whisper more than they speak. When you consider stellar remnants, you are not looking at failures or endings. You are looking at foundations. White dwarfs, neutron stars, and black holes each mark a stage in the redistribution of matter and energy. They influence their surroundings, shaping orbits, altering flows of gas, guiding what forms next. The universe does not hurry these processes. It allows time to stretch, to soften transitions, to let change unfold without urgency. For those who observe, patience becomes part of understanding. The sky reveals its stories slowly, across lifetimes far longer than one person can witness. As you rest with this view of stars being born, living, and fading, you may sense that time in the universe is not something to measure against clocks, but something to experience through continuity. What appears as an ending from one perspective becomes a beginning from another. And in that quiet exchange between light and distance, you are reminded that nothing you see is static, nothing is isolated, and every moment belongs to a longer arc that continues, calmly and without demand, into whatever comes next. As the universe continues to unfold, individual stars begin to gather into larger communities, bound together by gravity and time. These communities are galaxies, not static structures, but evolving systems shaped by accumulation, interaction, and patience. When you look at a galaxy, You are not seeing a finished object. You are seeing a long process paused briefly by light. Galaxies begin quietly. In the early universe, matter was distributed unevenly, with slight variations in density left behind from earlier eras. Gravity amplified these differences, drawing gas and dark matter into growing concentrations. Over time, these regions deepened, attracting more material and giving rise to the first galactic forms. There was no single moment of formation. Galaxies emerged gradually, assembling themselves from smaller pieces rather than appearing whole. In these early stages, galaxies were irregular and unsettled. Their shapes were shaped by circumstance rather than symmetry. Gas flowed inward along filaments, feeding rapid star formation. New stars ignited in clusters, illuminating their surroundings briefly before evolving onward. The environment was active but not chaotic. It followed rules, even if the outcomes were complex. Space rarely gives us simple answers. As time passed, galaxies grew through two primary paths. They continued to form stars internally, slowly converting gas into light and structure. At the same time, they encountered one another. Collisions and mergers were common in a younger universe where distances were smaller and motion was less orderly. These encounters did not resemble impacts in everyday experience. Galaxies are mostly empty space. When they meet, stars rarely collide. Instead, gravitational forces reshape trajectories, stretching and distorting structures over millions of years. A galactic collision is not a sudden event. It unfolds slowly like a long conversation between two systems. Tidal forces draw out streams of stars and gas. Orbits are altered. Star formation may increase as gas clouds are compressed. Over time, the galaxies may merge, forming a larger, more complex system. From a distance, these interactions appear graceful. Long arcs of light curve outward. Spiral arms elongate and bend. The process is patient, governed by gravity rather than speed. What looks like disruption is often a step towards stability. Numbers whisper more than they speak. As galaxies merge and grow, they begin to settle into more recognizable forms. Some develop rotating disks with spiral patterns. Others become more rounded, dominated by older stars and less gas. These shapes are not assigned. They emerge from history. A galaxy's appearance reflects its past interactions, its environment, and the pace at which it formed stars. Over billions of years, galaxies mature. Star formation slows as available gas is used or expelled. Stellar populations age. Bright, short-lived stars fade, leaving behind longer-lived ones. The light emitted becomes steadier, less intense. What was once active becomes calm. This aging process is not uniform. Some galaxies continue forming stars actively, fed by fresh gas from their surroundings. Others become quiet, their star formation largely complete. Environment matters. A galaxy's neighbors influence its future, shaping how it evolves over time. Silence is also a kind of data. The absence of star formation carries meaning. It tells a story of exhaustion, of gas lost or heated beyond usefulness. Quiet galaxies are not failures. They are systems that have reached a different phase of existence. Their light reflects stability rather than growth. When you observe galaxies at different distances, you are observing different stages of this evolutionary path. Nearby galaxies show signs of maturity. Distant galaxies appear younger, more irregular, more active. This is not because galaxies evolve differently elsewhere. It is because you are seeing them earlier in their lives. Time reveals structure gradually. Galactic evolution is not driven by intention or direction. There is no final form toward which all galaxies move. Each follows a path shaped by initial conditions and subsequent encounters. Some grow large through repeated mergers, others remain small and isolated. Diversity is a natural outcome. Within galaxies, smaller-scale evolution continues. Star clusters form and disperse, spiral arms wind and shift. Central regions may host massive black holes, influencing surrounding matter quietly through gravity. These central objects do not dominate by force. They shape motion subtly, guiding flows of gas and stars over time. Space rarely gives us simple answers. From a human perspective, it can be tempting to view collisions as destructive. In the universe, they are transformative. Mergers redistribute matter, trigger new star formation, and help galaxies reach long-term stability. Change does not arrive through sudden endings. It arrives through gradual rearrangement. There is something reflective in this process. Growth does not require isolation. Interaction shapes development. Systems evolve through contact as much as through internal processes. Galaxies become what they are through shared histories, not solitary progress. As telescopes look deeper, this evolutionary story becomes clearer. Deep field images reveal galaxies at many stages at once. You see beginnings and maturity layered together, arranged by distance and time. The universe offers a cross-section of its own history, visible in a single frame. Numbers whisper more than they speak. Interpreting this history requires patience. Astronomers look for patterns across large samples rather than focusing on individual examples. Trends emerge slowly. Exceptions remain. Understanding grows through accumulation rather than revelation. Galaxies do not evolve toward perfection, they evolve toward balance. Energy is redistributed. Motion becomes organized. Star formation slows. The system settles into a state that can persist. When you consider this, the night sky feels less static. Galaxies are not distant decorations. They are ongoing processes, shaped by time on scales far beyond direct experience. Their light carries evidence of long histories, written not in words, but in structure and motion. As this understanding settles, you may notice a shift in how distance feels. Farther no longer means simply remote. It means earlier. Each galaxy occupies a position not only in space, but in time. And as you rest within that layered view, the universe appears not as a collection of isolated objects, but as a continuum of change, unfolding slowly, guided by gravity, shaped by interaction, and always allowing time to do its quiet work. Light is the most familiar messenger from the past, but it is not the only one. As understanding deepens, it becomes clear that the universe carries its history through more than brightness and color. There are quieter signals, less intuitive forms of information that arrive without images, without warmth, and often without immediate clarity. These signals do not replace light. They complement it, filling gaps where vision alone cannot reach. One of these messengers is gravity itself. When massive objects move, accelerate, or merge, they disturb the structure of space and time around them. These disturbances travel outward as gravitational waves, ripples that carry information about events that may never produce visible light. They move at the speed of light, but they do not fade in the same way. They pass through matter with little resistance, preserving the imprint of their origin across vast distances. When gravitational waves reach Earth, they do not announce themselves with spectacle. They arrive as minute changes, so small they require extraordinary care to detect. Instruments must listen for variations smaller than the width of an atom. filtering out noise that would otherwise overwhelm the signal. What is detected is not an image, but a pattern, a rhythm that reflects the motion of distant masses long ago. Space rarely gives us simple answers. Gravitational waves allow you to sense events that occurred millions or even billions of years in the past, events hidden from telescopes that rely on light. The merger of black holes, the collision of neutron stars, the collapse of massive objects leave signatures that can be felt long after the light has faded or never existed. In this way, gravity becomes a record keeper, preserving moments that would otherwise remain unknown. There is a quiet shift in perspective here. Observation is no longer limited to seeing, it becomes listening. The universe offers information through motion and tension, through changes in structure rather than changes in brightness. Meaning arrives not as an image, but as a trace. Another messenger travels even more quietly. Neutrinos are nearly massless particles produced in vast numbers during nuclear reactions, stellar explosions, and the early moments of the universe itself. They interact so weakly with matter that they pass through planets, stars, and entire galaxies without pause. Trillions of them pass through your body each second without leaving a trace. This elusiveness makes neutrinos difficult to detect, but it also makes them valuable. Unlike light, they are not easily absorbed or scattered. They carry information directly from their source, often escaping regions that light cannot. When neutrinos are detected, they provide a rare glimpse into environments otherwise hidden from view. Silence is also a kind of data. Detecting neutrinos requires patience and humility. Large detectors are placed deep underground or beneath ice, shielded from interference. Even then, interactions are rare. Most neutrinos pass unnoticed. What matters is not the volume of detections, but their timing, direction, and energy. From a handful of signals, entire processes can be inferred. Neutrinos allow you to sense the inner workings of stars, the core of supernovae, and possibly the earliest moments of cosmic history. They arrive from the past almost untouched, carrying information that has not been filtered by expansion or dust. In their quiet passage, they offer a different kind of memory, one that does not rely on light at all. Numbers whisper more than they speak. There is also a way in which gravity reshapes light itself, allowing you to see farther than distance alone would permit. Massive objects bend the space around them, causing light from more distant sources to curve as it passes nearby. This effect, known as gravitational lensing, does not create new light. It redirects existing light, magnifying and distorting images from the deep past. Gravitational lensing is not an instrument built by humans. It is a natural property of the universe. Galaxies and clusters act as lenses, bending light from even more distant objects behind them. Through this effect, faint galaxies become visible, their light amplified by mass along the line of sight. What you see through a gravitational lens is not a single moment but multiple layers of time aligned by chance. Light leaves a distant source and travels across an expanding universe, curves around massive structures, and finally reaches your detectors. Each step adds context. Each bend preserves history. Space rarely gives us simple answers. Lensing also introduces distortion. Shapes stretch into arcs, images duplicate or smear into rings. These effects require careful interpretation. What appears unusual is not an error, it is a clue. By studying these distortions, astronomers learn about both the distant source and the intervening mass, including dark matter that cannot be seen directly. This layered approach to observation reflects a deeper truth. The universe does not reveal itself through a single channel. It offers multiple ways of knowing, each incomplete on its own, but richer when combined. Light shows structure, gravity reveals motion, neutrinos carry interior information, lensing connects distances across time. There is something quietly human in assembling understanding this way. Knowledge arrives in fragments, signals are faint, certainty grows slowly. Observation becomes an act of synthesis rather than discovery. Silence is also a kind of data. These alternative messengers do not replace the night sky you see. They deepen it. They remind you that what is visible is only part of what exists, and what is detectable is only part of what matters. The universe has always been communicating. It simply speaks in more than one language. As you rest with this idea, the concept of looking into the past expands. It is no longer confined to vision. It includes listening to vibrations in space, sensing particles that barely interact, and reading distortions written into the path of light itself. Each method carries its own limitations. Each reveals something unique. None offers a complete picture. Together they form a more patient understanding of time, one that respects complexity rather than seeking final answers. Numbers whisper more than they speak. When you consider these ways of knowing, the universe feels less distant and more layered. Past events are not gone. They continue to arrive, quietly, through channels that require attention rather than urgency. And as this chapter settles, you may sense that looking back in time is not a single act, but an ongoing process of listening, one that invites stillness, rewards patience, and reminds you that understanding often emerges not from what is loud and bright, but from what moves gently through the dark, waiting to be noticed. As the search for understanding extends beyond stars and galaxies, it naturally turns toward planets that orbit other suns. These distant worlds do not announce themselves with clarity. They are faint, subtle, often detected only through careful measurement and patience. Yet within these small signals lies a quiet question that has accompanied humanity for as long as we have looked upward. Has life ever existed elsewhere, and if so, what trace might it leave behind? Exoplanets are not observed directly in most cases. Their presence is inferred through gentle effects, a star dimming slightly as a planet passes in front of it, or a star wobbling in response to a planet's gravity. From these changes, size, orbit, and distance can be estimated. Each detection is indirect, shaped by inference rather than sight. Even so, the growing catalogue of these worlds suggests that planets are common, and that many exist within conditions that could allow familiar forms of chemistry to unfold. Once a planet is identified, attention turns not to certainty, but to possibility. Astronomers look for biosignatures, subtle chemical patterns in a planet's atmosphere that might indicate biological activity. Gases such as oxygen, methane, or combinations that would not persist without continual replenishment become objects of careful interest. These are not proofs, they are hints, fragile and incomplete, shaped by context. Space rarely gives us simple answers. A biosignature does not guarantee life. Chemistry can mimic biology. Geological processes can produce similar signals. Interpreting these patterns requires restraint and humility. Each signal must be considered within the broader environment of the planet, its star, and its history. Understanding grows not from excitement, but from comparison and repetition. There is also the quiet reality of time delay. Light from a distant planet carries information from the past. If signs of life are detected, they reflect conditions that may no longer exist. A biosignature observed today could originate from a world that has since changed, cooled, or lost its atmosphere. The universe does not provide updates in real time. This delay reshapes the meaning of discovery. You are not searching for life as it is now. You are searching for life as it once was. Even within our own galaxy, signals may take thousands or millions of years to arrive. Any detection becomes a message across time, not space alone. Numbers whisper more than they speak. The search for intelligent life follows a similar pattern. Programs such as SETI listen for narrow-band radio signals or unusual patterns that might indicate technology. These searches are conducted patiently, scanning the sky without expectation. Most of what is heard is silence, punctuated occasionally by signals that turn out to be natural or human in origin. Silence is also a kind of data. The absence of detected signals does not imply absence of life or intelligence. It reflects limits of method, timing, and scale. Civilizations may not use technologies we recognize. They may exist briefly or choose not to transmit. Signals may have passed Earth long before listening began, or may arrive long after it ends. This awareness introduces a quiet humility. The universe does not owe a response. It does not coordinate its history with human curiosity. Searching becomes an act of patience rather than expectation. When you consider exoplanets and the search for life, the role of time becomes central. Each observation is constrained by delay. Each signal is historical. The present moment remains inaccessible beyond a narrow neighborhood of space. Everything else arrives late, shaped by distance and endurance. There is something reflective in this arrangement. The search for life elsewhere becomes less about finding confirmation and more about understanding continuity. Life, if it arises, does so within conditions shaped by physics and time. It adapts or fades. It leaves traces that may persist briefly or quietly disappear. In this sense, the search mirrors the way we study our own past. Fossils do not capture living organisms. They preserve moments, incomplete and silent. Atmospheres, too, may preserve chemical echoes of biological processes long after the organisms themselves are gone. Space rarely gives us simple answers. This does not diminish the significance of the search, it refines it. Each exoplanet studied, each spectrum analyzed, adds context. Patterns emerge slowly. Certain types of planets appear more promising. Certain stars offer longer stability. Knowledge accumulates through restraint rather than revelation. The human element remains present even when unspoken. Curiosity persists without urgency. The act of listening becomes a form of respect, an acknowledgement that understanding may come slowly or not at all. The universe is not withholding. It is simply vast. As you rest with these ideas, the concept of life elsewhere feels less dramatic and more integrated. It becomes part of the same continuum that shapes stars and galaxies. Biology, if present, would be another expression of cosmic evolution, shaped by chemistry, energy, and time. The search continues not because answers are guaranteed, but because attention itself has value. Listening to distant worlds, even in silence, deepens perspective. It reminds you that existence unfolds on scales that do not align with human expectation, and in that quiet recognition, the question of life elsewhere remains open, not as a demand for resolution, but as an invitation to patience, to listening, and to accepting that some truths arrive only as whispers carried across time. Astronomy often appears to be a science of distance, concerned with objects far beyond reach and scales far beyond ordinary experience. Yet, at its core, it is a science of time. Every observation, no matter how recent it feels, is a fragment of history arriving quietly in the present. The night sky does not show events as they are. It shows events as they were, preserved by light and carried across space with patience. When you look upward, You are not standing at the edge of the universe. You are standing at the receiving end of countless journeys. Each photon that reaches your eyes has traveled through expanding space, passed through dust, curved around mass, and survived time itself. What arrives is not a live transmission, it is a record. This perspective reshapes the meaning of observation. Telescopes do not reveal the universe in real time. They collect evidence. Each image is a document. Each spectrum is an archive. Astronomy, in this sense, resembles archaeology more than exploration. The goal is not to witness events as they happen, but to reconstruct what has already occurred. Space rarely gives us simple answers. Understanding emerges through comparison and context. A single observation rarely stands alone. It gains meaning when placed alongside others, arranged by distance, wavelength, and time. Patterns emerge slowly. Trends become visible only after patience has replaced expectation. This approach reflects something deeply human. History is never recovered directly. It is inferred from traces, fragments, and absences. The past does not announce itself clearly. It leaves marks that must be interpreted carefully. Astronomy follows the same path. Light carries information, but not intention. Meaning is drawn from what remains, not from what is complete. Numbers whisper more than they speak. Every star, galaxy, and signal contributes a piece to a larger narrative. Nearby objects offer recent chapters. Distant ones belong to earlier eras. Together, they form a layered record of cosmic evolution spanning billions of years. The universe presents its history not in order, but arranged by distance, requiring interpretation rather than simple reading. This layered structure introduces humility into the scientific process. There is no single moment that can be pointed to as the present of the universe. What is seen depends on where you look and how far the light has traveled. Time is distributed unevenly across the sky. The present exists only locally. Silence is also a kind of data. The absence of light, the lack of signals, the regions where nothing appears to happen all carry information. They define boundaries, they shape understanding. Gaps in observation help constrain models and clarify what is possible. History is not only written in what is seen, but in what is missing. Astronomy does not seek closure, it seeks coherence. The goal is not to know everything, but to know enough to understand how the universe behaves over time. Each new observation refines this picture, adjusting timelines, revealing earlier stages, or correcting assumptions. There is a quiet discipline in this work. It requires acceptance of limits. Some events will never be observed directly. Some eras remain accessible only through inference. This is not failure. It is the nature of studying a universe governed by finite speeds and vast distances. When you consider astronomy as a historical science, the night sky changes character. It is no longer a display of distant objects. It becomes a record of processes unfolding across time. Stars are seen at different stages of their lives. Galaxies appear at different points in their evolution. Signals arrive from moments that can never be revisited. This perspective brings a certain calm. The universe is not rushing forward. It is unfolding steadily, leaving behind traces that can be read by those willing to wait. Knowledge accumulates not through urgency, but through continuity. Space rarely gives us simple answers. The human role in this process is modest but meaningful. Observers do not control what is seen, they receive what arrives. Interpretation requires care, collaboration, and restraint. Certainty is provisional. Understanding remains open to revision. In this way, astronomy reflects the broader human relationship with time. Memory is incomplete. History is reconstructed. Meaning emerges gradually. The universe, like human experience, does not provide perfect records. It provides fragments that invite thoughtful assembly. Numbers whisper more than they speak. As you rest with this understanding, it becomes clear that every glance at the sky is also a glance backward. Every observation is a connection to something that has already happened. The present moment, in a cosmic sense, is always layered with the past. And in accepting astronomy as a science of history, you may find that the universe feels less distant and less abstract. It becomes a shared record, written in light, shaped by time, and still arriving, quietly and patiently, into the awareness of those who are willing to listen. As the journey comes to rest, one idea remains quietly present. The universe does not share a single, common present. What you see depends on where you look and how far the light has traveled. Time is not synchronized across space. Each region carries its own moment, arriving when distance allows. This understanding changes the meaning of observation. You are never watching events unfold as they happen. You are receiving light that has already completed its journey. Every star, every galaxy, every faint signal carries with it a portion of history. The sky is not a window into the now, it is a layered record of what has been. Space rarely gives us simple answers. Human understanding grows within this delay. We do not experience the universe directly. We read it. Light becomes the medium through which history is delivered, one message at a time. Photons carry evidence, not intention. Meaning is drawn from patterns, from consistency, from what survives distance and time. Numbers whisper more than they speak. Telescopes do more than bring distant objects into focus. They extend attention across eras. With each improvement, they allow older light to be received, quieter signals to be noticed. Looking farther does not mean reaching outward. It means listening longer, accepting the patience required to understand. There is something grounding in this perspective. The universe does not rush. It does not compete for attention. It unfolds at its own pace, leaving traces rather than declarations. Understanding arrives slowly, shaped by care rather than urgency. Silence is also a kind of data. In recognizing that there is no shared present, a certain calm emerges. You are not behind. You are not late. Everything arrives when it can. The universe offers its history in fragments, and those fragments are enough to begin understanding. As you release the need for immediacy, the night sky becomes less distant and more intimate. It is no longer something to master or decode quickly. It is something to receive patiently over time. And in that quiet exchange between light and awareness, you may sense that looking into space is also a way of learning how to wait, how to listen, and how to let understanding arrive gently without demand.